one with the locals seems to be the Frontier restaurant, and it's directly across the street from the campus on Central. And I don't know how good the food is there, but it looks pretty good. And I certainly see a lot of local people really seem to enjoy it. So that's our lunch. We also have a social hour tonight, and we will have food, maybe not quite as much as last night, but we will definitely have some food, and the menu hasn't been determined yet. And it's going to be pretty much set up similar to what we had last night. Want to mention the DVD discount. We really, why do we want to push these DVDs? Why am I obsessed with this? Because this is history right now. And people in the future, assuming our society survives, it will survive largely because of the kind of work we're talking about here. And if you have a set of DVDs in your hometown, that could be used to help especially the young people who are coming up. And that is the most important part of this as far as I'm concerned. The more young people know about this stuff, why do I think that? Well, because they haven't been around long enough to know that this can't be done. Very valuable. Okay, so yeah, get a DVD set, even if you weren't thinking of it. Think about it, because maybe you don't have time to watch them or whatever, but you might know some students down the street who will massively benefit from this information. And it's $100 off if you get them today. We have magazines, of course, and that's more archival material, and they're as low as $2 each on clearance. And we also want to stress the memberships. That helps the organization, keeps it strong and rolling, and especially gift memberships. That is a really neat gift to give people. And so I'd like to encourage that kind of behavior too. We're ready. Our next speaker, I first met him last year at our conference in Utah, David Yurth, who is from Utah. He lives in the Salt Lake City area. He has a dual bachelor's degree, English literature, creative writing, and journalism, with minors in chemistry, physics, math, and psychology. That's a pretty interesting combination right there. As he's matured, he has gotten a master's degree in organizational leadership. He's currently finishing a PhD in international business. He has his own company, which is called the Nova Institute of Technology. And what he has to say here is real important, so let's welcome David Yurth.
Well, the first thing I want to do is have you give another big round of applause to Maury, who is the king. Well, I bring you greetings from the Nova Institute of Technology. We have some new sponsors this year, the Global University, which is now beginning its campus work in Zurich, Switzerland, and Gearless Technologies, GTI Motorworks, and the SOAR Foundation. And we've got some stuff to talk about here that's really serious, so if you'll key up my next slide there for me, please. Okay, John. These are technologies that represent the best of Y-bias and angularity. This is a golf club designed to accelerate the velocity of your golf ball. You actually put a shotgun shell in the head of it. Right there. And when you make contact, of course, it detonates, and that does give you a degree of acceleration. This is the alarm fork. We'll be handing these out at lunch. If you eat too fast or eat too much, it sets off an alarm. And you're only permitted to eat then again when the green light goes on. This is the Bat Boy wing set, man's longest held dream to defeat gravity. Of course, you do have the landing gear, but when you reach a certain minimum velocity, you deploy your wings and away you go. This is from 1887. Of course, it shows how forward-looking inventors are, and you'll find common cause with a hot air dirigible powered by very large birds. And you'll notice that there is a safety device, OSHA compliant, a parachute. This is the cranium cooler. This is what Maury needs to wear after he gets done up here. It's the solar-powered Peltier chip head cooler with a fan that is designed to keep the gray matter cool and under control. And this, of course, is the deployable air wing version of the airbag for motorcyclists. A similar version for bicycles. The flying saucer submarine. By the way, these are all very real patents. All of them have a patent number. You can find them. We give appropriate attribution to absurd.com. They have a list of over 300 of these kinds of inventions with little write-ups. But this little baby is both a flying saucer and a submarine, the ultimate transportation device. This is the OSHA-approved gas factory. And for those of you who are deeply involved in capturing and bottling methane, this will give you some ideas. This, of course, is the replacement for the scuba gear. You just simply put on the hat, and you've got all sorts of plants in there, and of course they generate oxygen and convert the carbon dioxide. So it's a self-breathing device. We have to take some issue with the calculations with respect to the conversion rate between carbon dioxide and cactus. And of course, there is the hijacker injector seat, which was patented after the 9/11 events, and this is designed to tranquilize those who get out of hand in flight. And then there is, of course, the life expectancy watch. So instead of saying, I don't know how much time I've got left, you can be very precise about this. And then, of course, there is the paddle wheel plane. I'm not sure where they got this. I used to have a rubber duck that had things like that on it, so I'm thinking maybe that's kind of where that came from. And then, of course, there is the propeller leg for those of you with arthritic knees. You simply strap that baby on your leg, you tow your battery pack behind you. Of course, if that was one of Murray's hydrolyzers, you just hydrolyze it, run Brown's gas, run it through a fuel cell, provide power, and then run your motor. And of course, you never run out of fuel because you're sitting in it, right? And then, of course, there's the radar head. This is the precursor to the GPS. Miniaturization is everything, said our new wife. And then there is the redundant recumbent, which is for those of us who find ourselves overwhelmed by FaceTime on the computer. This is a real patent, and all these pieces have numbers. This is one of my favorites, the robo-skater. Every angle of the body has a wheel attached to it. So that these are all the different things you can do by deploying yourself in different arrays. And for those of us who like to surf but don't like all that shark stuff, there's the sit and surf. And then there's something wrong with the ergonomics of this one. I'm not sure how they got a patent on it. You sit on that after you put it between your legs, speed bumps could be an issue. There's the ski flyer, which of course is again an attempt to satisfy man's greatest desire. And then there's the snowmobile version. And then of course there's the subdermal watch for those of us who are chronologically challenged. You just sort of implant this under the skin on the back of your wrist, and you read the little LEDs through the skin, and that's a real patent, and they really made those. This is my next door neighbor. Oh, sorry. You sort of hook it on your feet and hook it on your hands and hook it on your shoulders and walk through the leaves. I'm not quite sure how you translate stuff out here into there, but hey, you know. Now, this is a cross between the Spruce Goose and the Titanic. And of all of the engineering I've ever seen in the last 40 years, this piece here is probably the most interesting. I'm not sure what that does. And then, of course, for those of you who are subject to somnambulism, we've applied for a second patent, which is a set of landing lights that takes you up to the stool. Anybody want to tell me what this guy's doing?
Methane.
We'll talk about it after. This is a rotating sail that generates electric power on a grid that drives the batteries that does something inside this boat. I'm not sure what that is. I don't know who did the vector calculations on this piece, but I think there's something a little out of whack with the center of gravity with this one. And so there's something for everybody. And in memory of our good friend Tom Vallone, who is not here with us today, the zero gravity squeezer. Okay, you can put us back to business yet. Life is just too short to get real serious. So how are we on time?
Oh, you got another minute or two for question and answers.
Do we care? Well, I'm really pleased to be here. This is really a treat.
You got about 45 minutes.
Oh, thanks. We're great. Thank you. Really appreciate the chance to talk with you. I've
Excuse
had
me.
a chance to hear from many of you on
minutes.
email. For those of you who have tried to contact me and not gotten a response, it's not because I was wearing my life expectancy watch and thought I was running out of time. It's because the people who are hosting our website sometimes can't find the landing lights and they don't transfer our information correctly. So let me give you an email address that you can send information or questions or requests to me directly. It's David Yurth, all one word, lowercase, at Comcast.net. You're welcome to do that. And we have a number of pieces of material that are available that you can make a request for, and we send them to you happily in ebook format without charge. Last year we talked a little bit about the standard model of physics, what's right about it, what's wrong with it, what we think we can do to ameliorate it, and today we're going to talk a little bit more about what we can do with what we think we know. But this is the baseline. The quest of modern physics has been to develop a model which correctly describes the role and dynamics of the interactions by which nature works. In order for the model which describes these interactions to be robust, it must not only accommodate phenomena which are known to occur, but must also accommodate all rigorously documented phenomena, predict phenomena which are as yet undiscovered, and allow for the inclusion of all rigorously observed, impeccably documented, carefully reported data from all sources. To be adequate, any universally applicable physical model must also accommodate the contemporaneous interaction between Descartes' physical stuff and the spirit stuff with equal cogency and grace. The standard physical model does some, but certainly not all, of those things. What we've tried to do by developing this new model of scalar physics is to say, we know what's wrong with the standard model. There are physicists among us, there are engineers among us, there are those among us who have spent a lifetime investigating why the standard model doesn't work. We spent a lot of time last year talking about the specifics. I'm not going to go through all of those things here again today. You're welcome to get a copy of this. We'll have it posted on PesWiki, and it'll be available through the Nova Institute site. So you're welcome to a copy of this PowerPoint presentation. What I want to say to you first is that what we know about the standard model can either be viewed from the top of the model or the bottom of the model in order to provide context. The top of the model is the Big Bang Theory. The Big Bang Theory has gotten a lot of traction. In fact, it is so vigorously defended now by the American Physical Society and by the current establishment in academia that enormous license is given to theoretical cosmologists to allow them to introduce sufficient fudge factors to figure out how to make the Big Bang model work. The fundamental error in the Big Bang model is simply this. The Big Bang model says that at some moment in time, there was a singular event of infinite heat and infinite density, which resulted in the creation of everything that's in the cosmos. And that from that single event, everything in the cosmos instantly expanded, and everything then went through this process at a fifth or sixth scale of organizing itself into the things we see with a telescope or a microscope. What that model suggests is that beyond that moment of instantaneous singularity, nothing is new in the universe. There is nothing new in the universe. What we know instead, based on the latest information that's available from science, from independent investigators, from all the reports and all the literature, is that nothing could be further from the truth. So Brian Greene and others like him are trying to develop models like string theory. And what string theory attempts to do is to say, well, we know that there are things happening down below the level of subatomic particles. We have some idea what those things are and maybe what they look like. We have some notion about what they do and how to describe them, but there's a whole long list of phenomena that are observed, rigorously reported, impeccably documented, which are not accommodated by the standard model. And there's a long and very interesting list of those things. This is just the tip of the iceberg. In our paper, we list 26 different specific categories. And while we're going through this exercise, I want to let you know that something really remarkable has happened with respect to this discussion. In October of 2007, a guy named Terry McGrath was issued a patent by the United States Patent and Trademark Office entitled Physical Quantum Model for the Atom. The quantum model that now describes the interactions that are embodied in the Y-bias model are now described in a patent. And if you'd like to get a copy of the patent, I'll put it here on the table so you can get the patent number, and it'll also be made available on our website. This is an extraordinary development. What Mr. McGrath did was to create a patent in a way that finessed the patent process. His patent is not so much about the model of the atom, although it is, but the reason he got a patent was because he patented it as a teaching technique, as a way of teaching people about what makes the model of the atom work and not work. And all of the particulars that relate to the things we're going to talk about in just a second, including the graphs and the diagrams, all the explanations, the simplified mathematics, all of the vocabulary, all of the citations with respect to the problems of the physical model that are solved by this new patent are all included in here. It is a remarkable piece of work, and I highly commend it to you. If you want to understand how atoms work, he's got it under control, and we owe him a debt of gratitude. It's a wonderful piece of work. There have been attempts over the last 10, 12 years by some who are known to you to fix what's wrong with the model. And all of this information is now available in the public domain. If you want to look at the mathematics, if you want to understand why it is that none of Maxwell's original electrodynamic equations are not taught in academia, not a single one of the original Maxwell's equations are included in any physics textbooks that are used in college-level physics anywhere in this country. It's not true in Russia, it's not true in China, but it is true in this country, and it isn't true in most of Europe. There are significant errors in the translation, and what Tom Bearden and Myron Evans and Larry Crowell and others have succeeded in doing is correcting those errors, so that if you really want to know what the quaternions he developed were really describing and how they really work, you can go to this piece of work, and it's available on the internet. Ruggero Santilli has done remarkable work in reformulating the model of hadronic mechanics. His book is available, Il Grande Grido, A Cry in the Wilderness. The reformulation of the laws of thermodynamics is a magnificent piece of work by Mahmoud Melehi. Suggest that you take a look at they're interested in hydrolyzing water into monoatomic hydrogen and figuring out what to do with it in a way that really works. If we're interested in replicating Bob Neal's engine, if we're interested in doing any of these kinds of experiments, this kind of information is indispensable to you. And I also cite this patent here by Mr. McGrath. All right, let's get down to business now. Maury King talked about the quantum foam. Quantum foam is a notion that comes out of string theory. And basically what it addresses is a concept that we talk about in semantic language that we don't have any mathematics to describe. The physical vacuum as a physical reality has long now been established since 1947 when Hendrik Casimir first demonstrated his Casimir theory. It is now clear, indisputably clear, that there is a physical vacuum. And out of that physical vacuum, contrary to the standard physical model, we also now are certainly clear that there is a way things are created and uncreated in every address, everywhere in the universe, simultaneously, all the time. Maury talked about Ilya Prigogine in his wonderful book, Order Out of Chaos. For a long time, theorists thought that the universe was in entropy and that the whole thing was slowly but surely imploding to a lower steady state. What people couldn't understand was how it is in the same universe, if all that is happening is a dissipative structure, how is it that we also see stars being born? If the universe is self-destructing to a lower steady state through dissipative structures, if that's the way it really works, how is it that new stars are born at the same time, in the same space, in the same universe? Well, thanks to the wonderful work of a man by the name of Per Bach, a Belgian physicist at the Brookhaven National Laboratories in Long Island, who did a piece of work called How Nature Works. You can buy his book now on eBay. They sell for about $400. He only had one edition, and I got lucky and got one. But it is the keys to the kingdom, because he describes in this book precisely how it is that disparate materials in a complex system organize themselves according to a set of rules which Maury referred to as self-organizing criticality. How does that happen? He amplified, described, and mathematically formulated the rules. If we take self-organizing criticality and the 5 pieces of that set and apply that to what we know about the observable world and contrast and compare that with what's taught in the standard physical model, we begin to understand how things really happen. We have Tom Bearden to thank for this diagram. He asks the right question. As Maury has aptly pointed out, as others of you have pointed out, as most of you know, there are phenomenological effects that operate in the natural world under certain circumstances where far more energy is released in one condition than was required to create the condition in the first place. The question nobody seems to be able to answer is, where does that energy come from in the first place? What is the source of this unending charge? And it is in the physical vacuum. We now begin to understand how the physical vacuum works. These are some of the things that happen that help us to understand how this all goes together. Are you familiar with these pieces? With Bell's theorem? With Sheldrake's morphic fields? The implicate order described by David Bohm? Are you familiar with Vladimir Poponin's phantom DNA effect? Anybody here familiar with that? Show of hands. Holy smokes. This is really critical. Here's something the standard model can't explain that is absolutely consistent with self-organizing criticality. and the McGrath patent, and the Y-bias and angularity theorem. If you go to the web, www.heartmath.com, you'll find the scientific literature posted by Russian scientist Vladimir Poponin. What Vladimir Poponin and his guys did, sponsored by the Russian Academy of Sciences, a 7-year project, was they built a light scattering chamber, a box, 3 feet cubed. They Faraday caged the building, they Faraday caged the room, they Faraday caged the box. What they were attempting to do was isolate and stabilize, sanitize everything inside the light scattering chamber so there was nothing there but what they put in it. All right? Triple redundancy in Faraday cages. So no cosmic rays, no electromagnetic, no radio frequency, no microwaves, no nothing impinging in that space. And after 7 years, they finally stabilized this chamber, and here's what it did. Along one wall, an array of LCD chips, just like the ones in your video camera, designed to pick up refraction from a laser array at 90 degrees and finely particulated talcum dumped from the top that floated down to the bottom. The talcum so finely particulated that in the absence of electromagnetic fields, no electrostatics in there at all, it took nearly 30 full minutes for the talcum to drift from the top to the bottom. When they shined the laser, dropped the talcum, the LCD chip, the CCD chips, picked up the diffraction of the light as those pieces fell down, recorded them, ran them into a computer, ran a fast Fourier transform to determine randomness. Is there any order in the way these talcum granules fall down through this chamber? After stabilizing that, they took a Petri dish. They put the Petri dish in, they dropped the talcum, they shined the light, they turned on the cameras, randomness. In the Petri dish, they put saline solution, the same salinity as human blood, sterile. Dropped the talcum, turned on the lasers, ran the cameras, ran the transforms, randomness. Out of the inside of the mouth of one of the technology people in the room, they take one epithelial cell, just one live human cell. They put it in the saline solution, they put the Petri dish in the chamber, they turn on the light, they drop the talcum, they turn on the cameras, they run it through, and guess what happens? Zero randomness. Zero. They thought their machine was broken. And they completely redid the experiment. It took them 3 more years. And they got exactly the same result. And then they discovered that not only does the field of non-local information organizing field effect extend a meter, a full meter from one cell, organizes physical material in the air at a distance. If you couple a laser beam of the right frequency, it amplifies the effect 1,000 times. And if you rotate the Petri dish 90 degrees, the pattern of organization rotates 90 degrees. Now, the Standard Model does not address that issue. Does not. Any more than it addresses Descartes' spirit stuff. How does that work? Well, we're going to tell you. Another piece, Gizen's CERN experiment, simultaneity, long-distance field effects. Are you familiar with this work? For those of you who are not familiar with it, here's the deal. If you take a positron and an electron is the negatively charged piece of matter that's a 5th scale organizational function in the Y-bias scale. A positron is positively charged antimatter. And science has now gotten to the point where they can actually create these positron-electron pairs. We actually have a diagram up here of what happens in a cloud chamber when you blast a gamma beam through the right stuff, and it creates these babies and spins them up. Take a positron-electron pair, put it in a gun. It's actually just a laser beam. Shoot it into a potassium niobate crystal. The potassium niobate crystal, because of its nature, separates the positron from the electron. Fiber optics, exactly the same length, out 25 kilometers in each direction, attached to a cesium clock that's good to 9 decimals. Shoot that positron pair into the crystal, shoot the pieces off in opposite directions. Just as it gets to the clock, change the spin of one, and what happens to the accommodating zero-sum spin of the other? It automatically adjusts at 0 delta t to 9 decimal points. 0 time. No time. How does that work? That's Gödel's theorem. Gödel's theorem says if you were to do that, that's what would happen. It's a quantum dynamic effect. The standard model in the math of quantum mathematics doesn't describe it because non-local field effects, simultaneity at a distance, is not accommodated. That experiment's been replicated hundreds of times. Critical to understanding what we're doing. Okay. Let's get past some of this. Oh, here's a piece. Look. We talk about gravity all the time. One of the notions that makes the standard model unmanageable is that there are 4 field effects, right? Gravitational field, electrodynamic, electromagnetic fields, strong nuclear force, weak nuclear force. What do they all have in common? They are linear. They are local. The standard model says they pre-exist the Big Bang, and that's how everything got organized, because the field effects were already there. They're not real sure how that happened, but that's an a priori assumption. It's the baseline, the bedrock of the standard model. What we now know is that in gravitational field functions, if you've read Whittaker's 1903 paper, little partial differential equation exercise, it says that gravity has transverse waves that undulate with instantaneous feedback between masses regardless of distance. That's Whittaker's description. The Einstein-Podolsky-Rosen formulation violates that, and that's why relativity has to have so many fudge factors in order to make it work. What we discover is that in a Russian formulation by the famous Russian physicist Plotnikov, there's a factor here called Z. You see that Z right there? That Z is the feedback loop. It's meant to describe what happens in the feedback between masses that's instantaneous between infinite distance. All right? Guess what happens if I push the right button? Guess what happens if we exchange that Z, sorry, where'd it go? For that Z. You know what that Z is? That's the basic formula for fractals. Instant feedback between information that is bounded and information that is unbounded. This is what provides for self-similarity at all scales in the natural world. And guess what happens if we substitute that formula in the equation? All of a sudden, planetary motion, archetypal forms, the precession of planets, adherence to the Fibonacci relationships. You know what the Fibonacci numbers are? I mean, these are the magic numbers, right? The Fibonacci numbers. They're found everywhere in nature, at the bedrock, operating in the physical vacuum. If you exchange the fractal formula for Plotnikov's instantaneous information exchange function Suddenly you now have a mechanism that operates across the infinite distances of the universe without attenuation and without time lag. Well, there's simultaneity. That is simultaneity, and guess what? It has an analog in physical interactions that are local. This is part of the clue. These are the Fibonacci numbers. It's the only series of numbers in mathematics anywhere where the inverse of the function is equal to 1 plus the function itself. It's a magic set of numbers. If you map it out this way, it's self-similar. If you map it this way, it creates the nautilus. Where do you find this set of shapes? Where do you find that set of curves? Where do you find that angularity? That's how it looks if you map it. But if you look in nature, baby, there it is. There it is. That's the Fibonacci numbers at the cosmic scale. Now the question we got to ask ourselves is, does that archetypal shape based on those Fibonacci numbers and all the dynamics of self-organizing criticality that we now know about only operate at the basic cosmic scale? Is it a special case? Is that the only place we're going to find it? I don't think so. Okay, here we go. This is self-organizing criticality. This is the roadmap. There are 5 rules. Maury talked about some of them. He's right on the money. In order to recognize self-organizing criticality in a complex open system, you see punctuated equilibrium. The events that happen, like earthquakes, are related to each other in no linear way, but they have a logarithmic relationship. For each one of these of this magnitude that happens, there's so many of this magnitude. And for each one of those of a secondary magnitude, there's so many of these of a tertiary magnitude. And guess what happens when you map them out? You get a fractal. So, fractal geometries, you see fractal geometries everywhere in nature. In fact, the only place you don't find fractals in nature is where we've been. And that's why the Drug Enforcement Administration has spent so much money building pattern recognition routines for high-altitude satellite photography to recognize things that don't belong in nature because they're not fractal, like cocaine labs and roads and things. Quantum thresholds are critical. It's very simple. You want to move a boulder? You got to reach a quantum threshold. You don't just move it a little bit. You either move it or you don't move it. It's like the excitation states in electrons. They're either in one place or they're in the other. They're nowhere in between. So this quantum energy threshold state is categorical, and they all combine in the Fibonacci series of numbers. That's the organizing software that operates in the machine language of the cosmos. Einstein recognized vector magnetic potentials. Physics hates it because vector magnetic potentials gives the lie to all of the fundamental issues that they're trying to use now to continue to justify the Big Bang and the quantum electrodynamic model of the universe. It's the vector magnetic potentials that operate at the 0 point. People have trouble getting their hands around this idea of Y bias. Let me make it easy for you. Take a balloon. It's like the old physics thing. Guy draws a circle, says, this is a cow. Take a balloon. Call it information. Everything in that balloon, everything in, on, around it is information. And this information can be organized at any scale of criticality, at any layer of complexity. It can have spin, it can have polarity, it can have a time domain function, it can have mass, it can have a waveform, it can have a velocity, it can have any of a number of characteristics. Take that balloon spin it and send it out through space. It's got to be spinning because nothing operates in the universe at any that does not exhibit spin. It's intrinsic to the nature of the magnetic potential. Take another balloon. Call this one hot, dry air. Call this one cold, moist air. Shoot this one off at another angle on the Y bias. And as this one comes spinning along, it intersects this one. So you now have a Y bias interaction at some angle. Angularity is categorical, isn't it? In your work with physical materials, don't you find that angularity makes all the difference in the world? I mean, in all kinds of interesting ways, we discover that there are optimal and minimal effects of angularity. It's particularly true in fiber optics, for example, but in all kinds of interactions. And if you have hot, dry air meeting cold, moist air at the right angle under the wrong circumstances, what do you get? You get a set of archetypal forms called tornadoes. That's Y bias and angularity. That's how it works. So if you take this to the finest scale, at the physical vacuum, the intersection between the physical vacuum and the first organization. In the physical vacuum, everything, as Maury says, is chaotic, totally undifferentiated information potential. It is robust, and it is constantly in motion. Where virtual ensembles, not yet made real in physicality, but potentials, a balloon, arise in the physical vacuum and intersect other virtual ensembles that have other potentials. And they intersect. If they intersect at an optimal angle, the product of that intersection is a new scale of complexity. There's nothing in between. As those, now what we call them in the language is a qubit, they're really subquarks. If you take those subquarks and you intersect them at an optimal angle under optimal conditions, you get quarks. If you take quarks, 6 kinds of 6 different colors of 6 different sets of attributes, quarks and antiquarks, and you spin them and you bang them together at the right angle under the right circumstances, what do you get? You get 26 different kinds of subatomic particles, hadrons and electrons. If you take hadrons and electrons and you spin them around and put them in the right circumstances at the right angle of intersection, you create the right set of relationships with the right kind of spin, what do you get? You get atoms, and you get molecules, and you get the physical world, and you get solitons, planets with moons, solar systems with planets, galaxies with stars, supergalaxies of galaxies. And all these rules all operate in conjunction with the Bohm-Aharonov experiment. This is the seminal experiment that proves categorically that non-local scalar field effects arising at the baseline where the physical vacuum intersects the material world, non-local field effects affect what happens with magnetic potential regardless of how you screen them. They cannot be screened because they're intrinsic to the material. They're part of everything. This is not, as the scientific model says, a model that is built from the outside in, where we take a set of observations and throw them on the wall next to another set of observations that we've thrown on the wall, and then we try to figure out what those things mean with respect to each other. And we make up new particles called gravitons, and we make up all kinds of words to describe things that our models don't address, like dark matter. I mean, what the heck is that? If our model of gravitational field effects was correct, if our notion about mass and magnetism and time, about gravitational field effects and the way things come together was correct, we wouldn't need dark matter and dark energy. The model's wrong. There's no such thing. if you look at the way the stuff really works, what you discover is that mass is a product of primary interactions at the 0 point. Until you get to protons, there is no mass. No mass. The reason we know that is because quarks are not subject to gravitational field effects. That's why Ruggero Santilli got into a real contest with Murray Gell-Mann right after he got the Nobel Prize for the discovery of quarks. Santilli got in his face and said, there's no such animal. And even if there is, it violates the Pauli exclusion principle. Two real things can't be in the same place at the same time. And they got into a real contest, and of course Gell-Mann had the juice, and Santilli went back to Italy. And he was blackballed. He never would publish another paper. He was nominated twice for the Nobel, once in physics and once in chemistry, but because he disagreed, he was no longer involved in the business. So, mass is a product of underlying interactions. It is not primary. It is not intrinsic. Tommy Bearden is wrong about that. Look at this diagram. Do you recognize what this is? This is a photo of the coronal effect, what happens with a mass coronal ejection event on the sun. And what they have now discovered, Talbot and the guys who did this work, discovered that these little vortices, these things, these strings coming up through this black hole, this dark spot on the surface of the sun, is an upside-down tornado that is orders of magnitude hotter at the top than it is at the bottom. What have you always been told about the sun? That it's hot at the center and it cools off as it goes out. It's not true, folks. The model of the sun proposed by astrophysics is totally backwards. The surface of the sun is orders of magnitude hotter than it is at the center. And why is that so? Because these upside-down tornadoes, bounded by a nearly perfect vacuum that operates at nearly 0 degrees Kelvin, operate in such a way that they concentrate energy with the greatest of all possible efficiencies. They are always hotter at the top than they are at the center. Always. On Earth, we have exactly the opposite. Tornadoes are far more powerful at the business end than they are up on the top. And so are hurricanes, and so are waterspouts, and so are all the other vortical kinds of phenomena that we observe. What did I do with my unit? Oh, he covered it up. All right. This is what gives the proof to the lie. Don't know if you heard this on the 10 o'clock news. I don't think anybody did, because I don't think anybody announced it. But the collaboration at Stanford succeeded in creating electron-positron pairs with demonstrable measurable mass by banging light waves together. How does that happen? It's not supposed to happen. It's a fundamental violation of the Standard Model. They knew it could be done. Took them 6 months. Took about 60 of them to figure it out, and they did it. And they did it second time. They did it third time. They made it happen. They created mass from photons. Mass is not intrinsic. It is a product of an underlying interaction. And so is gravitational field effect, by the way. And so is magnetism, by the way. We've talked about that. These are the scales. This is how it works. And you can see all of this stuff. We'll zip through some illustrations here. This is from the McGrath patent, diagramming for everybody to see that virtual ensembles become subquarks, become quarks, become hadrons and electrons. Do we know that electrons can be split? Have you ever heard about anybody splitting an electron? I invite you to go to the website and Google Humphrey Maris, M-A-R-I-S. Brilliant Scottish physicist. Humphrey Maris has isolated electrons in bubbles of cryogenic hydrogen at 0.2 of a degree above 0 degree Kelvin, and when he bangs them with a radio frequency signal, the bubbles split and they take one half of the electron to one direction and the other half in another. The mass of the electron goes in one bubble and the waveform quantum function goes in the other. They are bifurcated in a physical interaction. The standard model doesn't allow that. Okay, you know what that is? That's a photographic image taken from a scanning tunneling electron microscope assisted with some image enhancement software of the smallest embodiment of physical matter in the universe. It's called the Bose-Einstein condensate. And if you'll look at the way that baby is constructed, at 0.1 Kelvin, 1/10 of a degree Kelvin above absolute zero, the Bose-Einstein condensate manifests every single condition that is required in order for Y-bias and angularity to operate. Every single one of them, including critical angularity and the relationship between the pieces. And look at that. It counterspins at the equator. Everything is connected. There are toroidal shapes. It is a standing wave phenomenon. They got a Nobel Prize for it, and boy did they deserve it. Allowed to have a 1/10 Kelvin increase in temperature, guess what happens to this baby? The information contained in that shape at 1/10, allowed to have an increase in temperature to 2/10, becomes 22 other kinds of mass. It instantly separates in a vacuum at virtual 0 degrees. It instantly bifurcates into 26 other kinds of material. And if you drop the temperature, it goes right back together. It's a fantastic piece of work. Everything we're talking about is embedded. If you look at it as a standing wave, here's the important business. This center and these gaps are 100% coherent with respect to the Fibonacci series. There's no variance between a perfect Fibonacci series and the gaps and spaces demonstrated by the Bose-Einstein condensate. That's the latest mathematical model of a quark. They had a hard time understanding how 3 quarks can fit together in the same space at the same time and create matter. There's a brand new model. Some of it comes out of Terry McGrath's work. This is a model that comes out of the University of Maryland. It's a really interesting piece of work. And what they diagram on this site is all the different arrays that are possible with 3 quarks that come together to form a kind of matter. It explains with real clarity why 99.8% of all the matter in the world is comprised of 3 basic quarks, and everything else that doesn't fit is made by the rest. All of the exotic pieces are unstable because their Y-bias interactions are not optimal. This is an optimal configuration, and this slope angle here is also an optimal configuration. So we've got 5th scale stuff. This is where we find gravitational forces. This is the first place we find electromagnetism. It's the first place we find the strong and weak nuclear forces. It's the first place we find real mass. It is not until you get quarks forming together to create hadrons and leptons that you have these field forces operating. They are not a priori, they are not pre-existent, and they are not the only field effects that operate in the universe. They're just one set of local linear field effects that are the products of underlying interactions. And for every place you find local linear field effects of this variety, you must, by definition, also find non-local, non-linear field effects of the kind that make it possible for the phantom DNA effect and Gizan's simultaneity at a distance to operate. Those are natural functions, and you find them everywhere, and that is the domain of Descartes' spirit stuff. Those two circles are what happens in a cloud chamber when you drive gamma radiation through the cloud chamber, the electron and the positron. Look at those shapes. You're seeing them in 2 dimensions, but if you saw them in 3 dimensions, guess what they look like? They're vortices. At these fundamental levels, these vortices operate. What this means to us in practical terms, this is what it looks like when a proton disintegrates into a quark. This is Shoulders' work. This is what happens when you take a plasma, you allow it to implode, you drive it with a charge cluster into a silicon-covered aluminum foil. You actually penetrate that foil, you can track it, you can look at it with an electron microscope. This is what they look like under the electron microscope. This is a charge cluster. He's actually got a picture of it, and they arrange themselves, and there's a quantum series that happens with these charge clusters. 1 micron, a millionth of a meter, and they join up to form a circle that is 20 microns in diameter, and these rings join up to create a tertiary scale, which was discovered by Russian scientists in 1994, and it is 50 microns. And those 50 microns, there's nothing in between. Nothing in between. This is what the charge cluster is doing, and we are grateful to Dr. Banchoff and his colleagues for helping us to create this mathematical model of the torus that is the self-organizing form, the archetypal self-organizing form that the electrons get into. This is what they do as they join each other. Standard model says all those electrons, all negatively charged, ought to just blaze off away from each other as fast as they can. And they don't. They self-organize themselves in this way, and that's how it looks. This is a software-enhanced photo provided by IBM, a photograph of an atom. That's as close as they could get to photographing the atom with its constituent protons and neutrons in the center and capturing in, guess what, balloons, information bubbles, the electrons, and the other pieces of this thing that fit together. I think it's a pretty extraordinary photograph. This is a photograph of gold foil under a tunneling electron microscope. These are atoms, individual atoms that operate and arrange themselves in this absolutely invariant lockstep between this boundary and this boundary of the material. We can actually take photographs of atoms. This is an enlargement of the nucleus of the atom that you saw in the prior photograph. We give credit for this to the people from PhotoSearch and to IBM. There's the torus. Only that thing is 200 meters in diameter. That's a smoke ring that was blown off of the top of Mount Etna when it erupted about 12 years ago. It's exactly the same form. This is what a vortex looks like as a fractal formula. Banchoff and the boys did this one as well, doing some research into tornado mechanics. And this is what that stuff looks like in the real world. That's Hurricane Katrina from the satellite. Phallico-solitons, you can do this in your swimming pool at home if you want to. It's a very interesting experiment. Take a frisbee, put a handle on it, spin it and lift it out. Give it about 10, 15 seconds and you'll find somewhere in the surface of your swimming pool another vortex will create. And if you put a drop of ink in the first one, you'll see that ink trail all the way under the water to the other one. That's a 7th scale manifestation of exactly what's happening at the 0 point. If we know how that works, and now we do, why are we bound to burning rocket fuel to get stuff into orbit? I mean, what sense does that make? Gravity is a product. It's not an a priori kind of field effect. If we know what dynamics operate to create it, is there any cogent reason why we can't create the conditions that mitigate gravitational field effects in a locale? We can, and some of us have, and others of us will. It's coming. And when it does, everything about the world we live in is going to change. All right? So, there's your vortex. There's a soliton. There's a soliton. There's our solar system. And with respect to the Fibonacci series of numbers in our solar system, the separation of the masses and their orbitals around the sun conforms to a perfect Fibonacci series with a variance of 0.00043%. And there it is. If information transport is limited by the speed of light in our universe, how the heck does that happen? That thing is 100 million light years in diameter. How does information from one side of it get to the other side fast enough for this to operate in real time as a self-organizing system that operates with criticality? It is because of what we know about the way the universe operates as a dynamic system, being created and disaggregated at every scale, in every address, in every moment, everywhere, in all when, across the cosmos. Below a certain scale, there is no time. Time is a product. It is not an a priori condition. It is a dimension with its own energy density. If we know that and understand how it works, why don't we use it? Let me sum up. These are just examples of some of the cool things we see. This is a black hole thing where you're seeing entire galaxies being spun apart and eaten, stars being eaten by black holes. These are Hubble photographs. They're pretty cool. The universe is not a clockwork mechanism. And all of these other things at the end of this summing up. These are some of the publications, some of the documents that are available through the Nova Institute of Technology. We got a brand new one that we're working on now called the Guerrilla Warfare Handbook. And it's a strategic guide to innovation management. Look, guys, we all wear the same inventor hat. We're all making the same mistakes. We're all being subjected to the same kinds of influences and operating in the same kind of dynamics. It's a kind of warfare. What we know is that Ho Chi Minh kicked butt on the mightiest army in the history of the world. He knew some things that we need to know. So what we're doing is writing this book, 17 chapters, clues, hints, tips, strategies, and tactics for helping you be smart and be successful about working together to do what Maury King calls for, creating a world that works for all of us. All of these are available without charge. Just send me an email, and I'll be happy to send you a copy. The only thing I ask in return is that if you ask for it and I send it, I want to hear from you. I want to know what works. I want to know what doesn't work. I want to know what you know that I missed. So I want your contributions, and my intention is to make this stuff available to everybody whenever you want it, whenever it's useful to you. Thank you so much for your time. Appreciate it.
Okay, ladies and gentlemen, we've got about time for one or two questions. Do we have one or two quick questions for Dr. Yurth? Okay. Make it real quick, and then we're going to do lunch.
Has there been any discovery of a single radiant vacuum presence that manifests itself as all these points in space?
Say again, please.
Hold it close to your mouth.
Yeah. Has there been a discovery or observation or anything of a single radiant presence that's smaller than all the quarks that it manifests in all space-time simultaneously?
No, not that I'm aware of. What I am aware of is that there is simultaneity in a single kind of dynamic that seems to operate everywhere. It seems to operate everywhere. According to Y bias and angularity, instead of a big bang, because these big self-organizing events that happen with what we call punctuated equilibrium, the earthquake in China was punctuated equilibrium, big time. All at once it happens. It didn't sort of slowly come together. It just happened big time. A volcanic eruption is punctuated equilibrium. It happens in big time. Instead of a big bang, we think what may have happened was the operation of an enormous black hole that was a 10 on the black hole Richter scale, for which there are 9s and 8s and there are 7s that we see happening in the heavens all over the place. As a recurring event, that is entirely likely and we think more consistent with what we see in nature.
Ladies and gentlemen, David Yurth. Thank you, sir. Okay, let's take a 30-minute break for lunch. We'll be back here at 1 sharp after the...